Hello everyone. Today we do 2.2 vectors in 3 dimensions. So we learned section 2.1 about vectors in 2 dimensions, right? So 2 dimension means we did that previously, XY plane or Cartesian coordinate system, right? So today we do 3 dimensions, which is XYZ plane. Okay, so let us do this. 1 dimension number line, right? We did that last time. So this is a number line. One dimension. So let's denote D as dimension, right? So number line we called real number line, right? So real. So we have a fancy mathematical symbol there. So this means a real number. So real number, real number include fractions, which is what is called fraction, rational number, right? Rational number and natural number, and so on, right? Okay, let me write down this one. All right, then 2 dimension XY plane. This is XY plane, 2 dimension, right? Or we say the Cartesian coordinate system. Okay, 3 dimension, X, Y, Z, right? So this is X. I'm not going to draw it, but I will try my best. So this is X, and this is Y, and this is Z. Oh, so good. All right. So this is origin, which is 0, 0, 0, right? So we have a order pair, triple pair then, right? So we have order pair, let's say the 1, 2. We called this is ordered pair, right? Now this is 0, 0, 0. That is X, Y, Z, right? So triple, no, ordered pair for the 2 dimension, right? Ordered triple? So ordered triple. And also we can say that Cartesian coordinate system in Hindi here, 2D, 2 dimension. Here we say that 3 dimension. Cartesian coordinate system in 3 dimension. Yeah. Okay. Look, this is X for the positive part. So since we said that X equal to 0 here, This will be 1, 2, 3, 4, and so on, right? Then here will be -1. So everything will be this part. It's a negative for the axis, x values. Yeah. Okay. Now looking at the y-axis. So this is 1, 2, 3, 4, 5, 6, and so on, right? And then this part will be negative. So I want to make a straight. Is it straight? Not really. A. So let me do. Yeah. So that is negative. This is x. Yeah. And z axis. So this is 1, 2, 3, 4, 5, 6, and so on, right? And this part is negative. So -1, -2, -3, and so on, right? So this is negative z. Okay, let's plot the point 1, -2, 3. 1, -2, 3. Okay, so look, 1 for the x. Let me write down. This is x, y, z. So 1 is here, and -2 for the y-axis. So let me draw this way. So 1 is here, and then I want to make a parallel with y-axis. So this one is not the straight now. So let's pretend straight. So I want to make a parallel with the y-axis. Yeah, was not the. Let me do one more time. So sorry about that. Okay, so I just draw parallel the line at 1 with the y-axis. Okay, then -2, I want to plot y equal to -2. So start to x equal to 1 here, and then -2. So this is 0, right? So we're going to this way 2 units. 1, 2 units will be -2. So it's about here. About 1, 2. Yeah. All right. Now, z equal to 3, right? So we don't go to here for z. So we just make a parallel again from here. That is y equal to 2, right? So parallel with a little bit off again. So parallel with the z-axis. So from here, we can just approximately plot the point 3. So 1 unit, 3, 2 units, 3 units, right? So 1, 2, 3. So that will be 1, -2, 3. Yeah, make sense? Okay, let's do one more. Let's plot the point 4, 3, negative 5. How about that, right? 4, 3, negative 5. Okay, so this is 1, negative 2, 3. Okay, so let us do this. 4. So 4, 1, 2, 3, 4. Yeah, and then 3. So we make 1, 2, 3, 4. So parallel with the y-axis. Ooh, is it parallel? Just say uh-huh. Yeah, and then 3. So positive 3. So 1, 2, 3. This for y. And then negative 5. Oh, luckily we have a z-axis. So a little bit off, but scale is not that accurate, right? So negative 5. So you guys okay with this? From here, that is a 4, 3, and we want to plot the negative 5. So 1, 2, 3, 4, 5 here. Yeah. So 1, 2, 3, 4, 5. So that would be 4, 3, negative 5. Oh, you cannot see. All right. Make sense? Okay. Now, we're in 3 dimensions. So look this one. Let me explain to you. The plane containing x and y axis. We know that, right? XY plane, right? So we had in 2 dimension XY plane, right? But in 3 dimension XY plane is like this. Yeah, like this. Yeah, this is XY plane. Yeah. So in XY plane, we say the equation, this is the equation, z equal to 0. So let me denote just the equation, EQ, right? So z equal to 0, z equal to 1, z equal to negative 5, right? Z equal to 0, z equal to 20. Make sense? That's the equation. We call this is the XY plane. Make sense? Okay. Now, we put YZ plane is here. YZ plane. So we have a Z axis and then X axis and Y axis there, right? Okay. So we have a YZ plane. The equation is X equal to 0. So X-axis here, right? X-axis. And then we say that the equation is 0. Yeah, X equal to 0. Here, X equal to negative 10. Here, X equal to positive 7, right? Make sense? because this YZ plane moving along x-axis. Can you see that? Make sense? Okay, now XZ plane. XZ plane is like this. Yeah. So this is y equal to 0. So y-axis, my y-axis, this one you see here? Can you see? Y-axis? And then this is y equal to 0. Then moving this plane, XZ plane, here, y equal to positive 20, and y equal to 0, and y equal to negative 47. Yeah, I just picked any random number. Make sense to you? Okay, so think about this. We have xy plane, then equation is z equal to 0, right? So can you see, can you see the pattern? Yeah. So xy plane, the equation we say that the variable z is missing, right? So z equal to some number, right? And then yz plane, the variable is x is missing, so x equal to something for the equation. Yeah. YZ plane, the variable y is missing, so y equal to something, some number, right? Yeah. Why I'm doing this? Why it should be like that, right? Should be uh, along y, right? Moving along y, along z, along axis, x-axis, right? Make sense to you guys? YZ plane, x, no, YZ, hold on one second. XY plane, up and down, XY plane. Okay, along x-axis, YZ plane, along y-axis, YZ plane. I didn't make any mistake, right? Make sense? Okay, good. Woo. All right, let's move on. Look. So we have 8 regions there, octants. Yeah. So first octant here, this is XY. Oh, this blue green is the XY plane. We just did that, right? The equation in the case x equal, I'm sorry, z equal to 0, right? And this orange one, the orange one moving along x-axis. So this is YZ plane. In the case, x equal to 0. Yeah, the equation is x equal to 0. And then purple one, the purple one, it should be like this. I need to see from my point of view, right? So this plane, which is XZ plane, moving along y-axis. So in the case, the equation is y equal to 0, right? Okay, now let's talk about the first octant. So here, this is the first octant. Look, everything is positive. This is the reason, okay? Can you see that? Yeah. So here is XZ plane. Here is YZ plane. Here is XY plane, right? This region we called first octane, and then XYZ is everything is positive. Yeah. Second octane, below the first octane, then which one is negative? Z is negative, right? Okay, let's move on. Third one. Third one, look. This is a y-axis, yeah? Which one is negative? Y is negative there, right? Look, y is negative. And then the number 4, below number 3, octane, right? Which one is negative? Z is negative. But we knew that y is negative, right? So y is negative, z is negative, right? Okay, number 5. Number 5, go there. Yeah? So here, number 5, which one is negative? X-axis is negative, right? So we have negative there. How about below XY plane, right? So Z is negative. And then we had X is negative there. Yeah? Okay, number 7, way in the back. So way in the back, X is negative, Y is negative. Can you see that? All right, very good. And then under the 7, we have 8. We knew that X is negative, Y is negative. Under the XY plane, Z is negative, right? So everything is negative, all negative. Make sense? Very good. Okay, let's move on. So let's talk about distance formula. Let me write down distance formula. Okay, so I wrote down distance formula. If we have two order pairs in 2 dimensions, right? XY plane, then the distance formula is square root of x squared, not x squared, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared, right? How about in 3 dimensions? How do you do? We just using same formula, but we just add the one more, the variable, which is z, right? So let's take a look. So this is the formula. So theorem 2.2, distance formula in space. In space means 3 dimensions. Yeah. So we have x sub 1, y sub 1, z sub 1, x sub 2, y sub 2, z sub 2. Then distance formula. So we are using just the d, first letter from the distance. So it doesn't mean anything. You can use a p, you can use any letter, right? So the first letter D, right? Then the same formula we are using, distance formula, but we just add the variable z, right? Okay, let's find out the distance between 2 points. So here is the example. All right, then using distance formula, that's it. So square root x sub 2, which is 2 minus 3 squared, plus y sub 2, which is 1 minus negative 1 squared, plus negative 1 minus 5 squared. Yeah. And this is square root of 41, which is 6.403. Yeah. Okay, so now we have equation of plane parallel to the coordinate. This is what we just did earlier. So parallel to xy plane. And then I said a tip. Think the missing variables, right? Then we can express the equation. What is missing variable in xy plane? So xy plane, we did that here, right? So g equal to any number. That is the equation. Now, number two, parallel to YZ plane. So YZ plane like this, right? So equation x equal to c any number. And parallel to xz plane like this. Then equation y equal to c any number. Yeah. Okay, so let's do example. Let me copy the questions here. Okay, so write equation of the plane passing through the point 317.7 that is parallel to the YZ plane. Then what is the equation? Good job. X equal to 3, right? Okay, how about this one? Find an equation of the plane passing through a point. We have a 6, negative 2, 9, 0, negative 2, 4, 1, negative 2, negative 3. The equation will be, so everyone has common, y equal to, it's a negative 2, right? And this is Desmos 3-dimension graphing calculator. So I plot all the point, and then I made a y equal to negative 2, the plane, which is xz plane, right? So here we go. So I can see the purple plot the point and the gray one, but not the green one, because I can see that z equal to the maximum is in the case of 4, but then z equal to 9 in the green, right? So that's why the green does not show here, but we can change that. Yeah, but I just want to show you how it looks like. So this xz plane covers all the points. Yeah, clear? Let me make a screenshot. Okay, let's talk about the equation of a sphere. So sphere is the 3-dimensional circle, right? So 2-dimension, we know that, the circle. Circle. Circle is a 2-dimension, right? 2D. Sphere is a 3-dimension, right? So we know how it looks like a circle. Sphere, make a like this. Okay. We know equation of unit circle, right? Um, let me denote it like this, equation of unit circle, which is x squared plus y squared equal to 1, right? In that case, r equal to 1, that's why unit circle, right? The definition of unit circle means the radius equal to 1, right? In general, the equation of a circle, it's hard to pronounce to me. Equation of a circle then x squared plus y squared equal to r squared, right? So in that case, we say the center at the origin, right? Center at the origin, which is 0, 0, right? Okay. Then sphere with the center at the origin, then equation is x squared plus y squared. And then we add a z because of 3 dimension, right? So z squared equal to r squared. This equation of sphere, right? So x squared plus y squared plus z squared equal to r squared. R squared. And then this is the center at the origin. So 0, 0, 0, right? Okay, then what if we have center with a different number, not the origin, right? So if we have equation of a circle with the center at AB, let me write down. Equation of circle. So we had x squared plus y squared equal to r squared, right? But in that case, the center at the origin, but what if a center at AB? Then I want to change that. How about this? Let me delete everything. So x minus a quantity squared plus y minus b quantity squared equal to r squared. Yeah. So center at the AB. Yeah. Okay. How about sphere has a center at ABC, right? So same format. So equation of sphere. So we have x squared plus y squared plus z squared equal to r squared. Will be insert ABC. Yeah. So there will be x minus a squared plus y minus b squared plus z minus c quantity squared equal to r squared, right? So center at ABC. So we call this is a standard equation of a sphere. Standard equation of sphere. Okay, let's make a box. Ooh. Ooh. Yeah, good. Too big. All right. Okay, let's do example then. So find the standard equation of a sphere with the center, this number, with a point. Okay. So I wrote down the equation. That is a standard equation of a sphere, right? Okay, then as we see, they say that it says center. Yeah, we have a sphere. Then center is this number, and then point. We don't know what this point from here. Oh, where we go? Center, and then here or here. Yeah, we can draw, right? All right. Then this is a standard equation of a sphere. We know ABC. Then we just need R squared. That's it. Then we need to find only R, right? And we can just make a square them, right? All right. So how do you find R? So R equal to, take the square root of everything, this one, right? So that will be x minus a. Let me just write down for you. Z minus c quantity squared, right? Let's just using why we need to find R squared, right? So we don't need this one actually, right? And just directly we can find out squared, right? So that will be x negative 1 minus 10 squared plus y, which is 3 minus 7 quantity squared, plus z, which is negative 2 minus c squared, right? Okay, can you please calculate? So we get 173. Very good. Okay, then we can write down equation of the sphere. So standard equation of the sphere. So x minus a equal to 10 squared plus y minus 7 squared and z minus 4 squared and r squared 173. Yeah. Okay, so I got picture from your textbook, which we just did now, right? Okay, so let's move on another question. So here you go. So we have 2 points. They say that PQ forms diameter about the sphere, right? Okay, let me bring the picture one more time. Okay, so I have a picture from the textbook. So P, this point, P here, and Q, from here, their diameter of the sphere. So, ooh, ugly sphere. So let's make that. Okay. Now we want to find the equation of the sphere, right? Then this is a standard equation of a sphere. Now we should know about the center. and then r, right? And r squared. Okay, how do you find the center? Only the given information is the diameter, right? Okay, so we want to find the midpoint. So let me write down how to find the midpoint, right? So midpoint formula. So normally we have the first letter M as a mid M. And then normally we have x of 1 x plus x of 2 over 2. Yeah, how do you find the middle number, right? We add 2 and divide by 2, right? And then we have y sub 1, y sub 2 over 2. We did that, right? But then we're gonna add one more variable because we are doing in space, right? 3 dimension. So z sub 1 plus z sub 2 over 2. Okay, so I needed the order pair. Oh, I can see that here, right? Okay, that will be, uh, let's make x sub 1, y sub 1, z sub 1, x sub 2, y sub 2, z sub 2, -5 plus 3 over 2. Please calculate. 2 plus 4 over 2 and 3 plus -1 over 2, right? So we get -1, 3, 1. So there will be center, which is ABC, center, right? Of a sphere. Okay, now we need to find R. So this is a diameter, right? Then we want to find the distance. Those diameter, right? And then we divide by 2. That will be the radius. Yeah. Okay, let's do it. So distance formula, I need those numbers. Square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 2 minus y sub 1 squared plus z sub 2 minus z sub 1 quantity squared. Okay, so there will be, I need the number, 3 minus -5 squared plus 4 minus 2 squared plus -1 minus 3 quantity squared, right? So that is the square root of 84. Oh, you cannot see. Okay, sorry about that. It's a square root of 84. Then r squared, which is the distance, which is diameter, right? So this is the same distance or diameter, right? So d over 2 squared, right? So that will be square root of 84 over 2 squared. So that will be 21. Can you double check this one? Okay, then we are done. Let's just arrange the equation of the sphere. So let me write down. So again, yeah. Okay. So there will be ABC. x minus positive 1 squared plus y minus 3 squared plus z minus 1 squared. Right? Equal to r squared, which is 21. Okay, so this is the Desmos, 3 dimensions. So I plot all the point, and then I made the equation there. So this is a beautiful sphere, and then I wanted to see where's the point, where is the blue point, green and red. Then nicely they shows us like that. Okay, so I'm gonna attach this screenshot into the lecture note. Okay, so here we go. And let's do vectors in 3 dimensions. So we learned yesterday, I meant 2.1. So vectors in 2 dimensions, right? So this section is about the 3 dimensions. So we add one more component, that's it. So we follow every properties and then scalar multiplication and then vector addition like that, right? So let's do it. Okay, so vectors in 3 dimensions. So let's take a look. Can you see that? We have a notation R3, right? So that means 3 dimensions. So 3-dimensional vectors. So vector V has, we have a component ABC. Then, oh, we have a vector V, another component. Vector W, we can express this component. 0 vectors, right? So this is 0 vectors, which is 0, 0, 0. X component, Y component, Z component, right? This is a vector addition. We did that last time, right? So we add X component with X component, Y component with a Y component, Z component with a Z component, right? And then we have a scalar multiplication. So we do distribute the scalar, then we keep the vectors. This is the vector. We know that this is a vector component form, right? Terminology, we should know that. Form. Okay, we learned the standard unit vectors last time. As a K 1001 Oh, we didn't have the last one, right? K, right? So I in 2 dimension 1, 0. J in 2 dimension is 0, 1. Now we have a 3 dimension 1, 0, 0 for the I. J equal to 0, 1, 0. K equal to 0, 0, 1, right? Then 2 dimension, right? So 2D. So we have like this, right? X, Y. So this is I hat, this is a J hat, right? Then 3 dimension. So we learn X, Y, Z. X, Y, Z. Then there will be I hat. This will be J hat. And this will be K hat, right? standard unit vector. Okay? All right. So let's do example so that we understand in 3 dimensions of vectors, right? Okay, so let PQ be vector with the initial point P equal to that, terminal point Q equal to that. Express PQ in both component form, standard unit vector form. Yeah. Okay. So we knew the formula. The formula has vector V, same as a line segment, PQ. Then the vector component form, you cannot say, okay, so x of 2 minus x of 1 for the first, second, and third, right? Okay, so that will be, I denote x of 1, y sub 1, z sub 1, x of 2, y sub 2, z sub 2, because this is the initial, this is terminal, right? So we need to follow that. So y sub 2, which is -4 minus 3, y sub 2, -3 minus 12, and z sub 2, 2 minus 6. Okay, so what do you get? We get -7, -15, -4. It's a vector component form. And standard unit vector, we are using ijk expression. So -7i hat minus 15j hat, -4 k k hat. Yeah. So that will be standard unit, not a factor, vector, vector form. Okay, so we have the same properties as the 2 dimensions. So here is properties of vectors in space. Space we knew 3 dimension, right? Okay, so vector V has the form, component form, x sub 1, y sub 1, z sub 1, w equal to x sub 2, y sub 2, z sub 2, c is the scalar. Then scalar multiplication, vector addition, and then we have a subtraction, vector addition, subtraction, scalar multiplication. Let me denote it this way. Vector addition, vector subtraction. Now, the magnitude of vectors, right? Magnitude of a vector. And then this is a unit vector. Right? Those are all the properties of vectors. Okay, let's do example. Example. Vector v equal to -2, 9, 5. W equal to 1, -1, 0. The first one, find 3v minus 2w, right? So how do we do? Scalar multiplication first. 3 times the vector v, -2, 9, 5, minus 2, w1, -1, 0. So we do distribute. So we get -6, 27, 15. We get the vector. and distribute to negative 2, 0. And that is negative 6 minus 2, 27 plus 2, 15 plus minus 0, right? So we get negative 8, 29, 15. Make sense? Okay, second one we have find 5, what is called the magnitude of W, right? Okay, so that will be 5. We have square root of 1 squared plus negative 1 squared plus 0 squared. So we get 5 square root of 2, which is approximately 7.07. Okay, how about C? Magnitude of 5W, right? So 5 is inside. So let's find the 5W first. So note 5W. So 5, 1, negative 1, 0, which is 5, negative 5, 0. So there will be square root of 5 squared plus negative 5 squared plus 0 squared, which is 5 square root of 2, which is 7.07. Oh, we get the same result. Oh. Okay, so note, we have a 5, magnitude of W is the same as magnitude of 5 vector W, right? But magnitude of V plus vector W is not equal to V plus W. Yeah. Would you like to check this one? So not same, right? And we have V plus W, magnitude of that is less than or equal to V plus magnitude of W. So if they're not same, right? Then how do we conclude? So magnitude of sum of two vectors is less than or equal to magnitude of first one plus magnitude of second one, right? So we call this is triangle inequality. Angle inequality. Okay. The last one, let's do it. Find a unit vector in the direction of vector V. So vector V is this one. Copy. Okay, so unit vector, the equation, the formula is 1 over magnitude of vector V times vector V, right? Okay, so let's do it. 1 over square root of negative 2 squared plus 9 squared plus 5 squared with vector V. Okay, then that will be that is square root of 110. 1 over square root of 110 and negative 2 in 5. Okay, that is negative 2 over square root of 110. We distribute 9 over square root of 110. 5 over square root of 110. Okay, so in the direction of V, so we're going to same direction of V, right? So direction, I direction, I direction, J direction, K direction, right? So there will be negative 2 over square root of 110 I hat plus 9 over square root of 110 J hat plus 5 over square root of 110 K hat, right? Okay, any questions? Thank you for watching. I will see you at the 2.3. Yeah, thank you. Bye-bye. Where is it? Where is it?